This is a video for MEI Core Pure Mathematics, Polar Coordinates, 1.3 Converting Between Forms. How do we change from polar to Cartesian coordinates? Well, let's have a look at this diagram. We can see here a point P, and that's defined in terms of r and theta, and we want to get x and y. Looking at the right-angled triangle, x equals r cos theta refers to this side here of the triangle, and y equals r sine theta refers to this side here. Here's 2 points defined in terms of polar coordinates. For the first one, we've got 3 pi by 3, so drawing a quick diagram, this length is 3 and this angle here is pi by 3. We know that x is equal to 3 cos pi by 3 and y is equal to 3 sine pi by 3. Cos of pi by 3 and sine pi by 3, if you're worried about the radians, convert back to degrees. This is going to be 60 degrees, and cos of 60 is well known, so x is equal to 3 over 2 and y is equal to 3 root 3 over 2. Looking at the next one, this angle of 5 pi by 4 up here, well, that's beyond pi. It's actually going to be down here, and this is my angle of 5 pi by 4, and the length is 5. So again, x is equal to 5 cos 5 pi by 4 now, and y is equal to 5 sine 5 pi by 4. Cos of 5 pi by 4 is minus 1 over root 2. Sine of 5 pi by 4 is also minus 1 over root 2. So x is equal to 5 over root 2, and that's minus, and y is equal to minus 5 over root 2 as well. There they are, worked out for you a little more neatly, and a useful check you can make is from your diagram, is it in the right place? This is first quadrant. It appears to be first quadrant from the diagram. And in the second case, this is third quadrant, and that is third quadrant. You could use that this angle here is pi by 4, and therefore you could use this right-angled triangle, knowing that your results are going to be negative in both cases because you can see it's third quadrant. Either way, a diagram is really useful. What about Cartesian to polar coordinates? Well, if we've got it in Cartesian form, so we know these two values, x and y, then we want r, which is the hypotenuse, and this angle theta here. Well, r we're going to get from Pythagoras, root x squared plus y squared, and theta we're going to get from this expression, tan theta is y over x, so theta will be the inverse tan of y over x. And note, we'll always get two solutions in the range minus pi to pi. So care must be taken in establishing the correct quadrant. And again, a diagram will help in that situation. So 2 examples of points in Cartesian coordinates this time. And again, I'm going to start with a diagram. This first point is at 12, 5, so it's going to be somewhere here. And I want this angle and this length. So r is going to be the square root of 12 squared plus 5 squared, and theta is going to be the inverse tan of 5 over 12. And I can see from my diagram that this is going to be a first quadrant angle. In the second case, minus 3, 4, I'm going to get something over here, and I want this angle for theta and this length. And again, r is equal to the square root, this time of -3 squared plus 4 squared, and theta is going to be the inverse tan of 4 over -3. And that's going to be a second quadrant angle. Here's that worked out for you. R comes out to be 13 in the first case. Arctan 5/12 is 0.395 or 0.395 minus pi. That's the alternative value in the range. Remember, we said there were always two. I want first quadrant, so I want just the 0.395. For the second case, we end up with r equals 5 and two possibilities for the angle, minus 0.927, and minus 0.927 is actually a fourth quadrant, it's actually down there somewhere, or minus 0.27 plus pi, which is the mirror image for that. So it's the second one I want because I want the second quadrant. The next video will look at polar curves and finding their areas.